Hello, Secondary 2 students. This is Mr. Green again. I hope you're doing well, and I hope you're taking care of yourself and your families. Hopefully you got the news from the district last week about grades for this term and how we're going to be a little bit flexible with that. Well, and by flexible, I mean everyone is going to pass this term because of what's been going on. Now, some of you hearing that are probably like, oh, I'm just not going to do anything and get away with, just passing, not doing anything. And I mean, can I really blame you for feeling that way? No. But I do think for a lot of you, especially in my honors classes, you want to have good grades on your transcript as you look forward to getting into college. Um, if if you get a pass on your transcript, that really does very little to distinguish you from other students. And in fact, so how it's going to work is for this term, we're not giving out any grades below a C. Okay, so you could get an F, like grade-wise, on Skyward, and you will get a P, meaning you pass this class at the end of the term, meaning you get the credit for the class, but the P does not factor into your GPA at all. Okay. If instead you take a letter grade, so let's say you work hard this term and you get an A or a B, well then you probably don't want to have a P on your transcript because that's the same as everyone that got, D's or F's, right? That's not going to distinguish you. And I know some of you don't really care about that, and that's fine. But I do want to kind of explain this so that you can understand kind of the consequences going forward of as you're making choices, how they're going to affect your future. So what you want to just be aware of is, yeah, you could take this as an easy out, and if you need to, I do encourage you to, okay? But this is a good way to distinguish yourself moving in for scholarships and for future academic endeavors. If you get an A or a B, that's going to be really good looking because you got an A or a B when all of this craziness was going down, right? That's going to look so good on your transcript, okay? And I guess like I don't want everything to be about grades in here. I hope you're trying to learn just for you, to better you as well. But I do just want to explain there are consequences to the things that you do, even though there's no way of failing this term. This still can be a really good thing for you if you try. And right now in this class, I'm not making it super hard. I'm trying to make it as simple as possible for you because I know this is a hard time and I'm trying to make it manageable for you. So I would hope that you put in some effort and try and get a letter grade. That would be really cool. I think that would look great on your transcript as you go forward in your future classes. And the thing about math is it builds on itself. So in future classes, you're going to need to know the stuff that we're doing now. And so if you kind of just slack off this last term and don't do anything, well, it's going to have consequences in your next classes where you won't understand quite as well. And so I really want you to consider that as you go into this, and I hope you'll still try, and I hope you'll you'll try and do your best to earn a good grade that'll go on your transcript. But I know too, this is a difficult time, and if you need to just take a pass with everything that's going on, I understand that, and I won't judge you for that, okay? So as far as things go, as we get close to the end of the year, so the deadline to kind of decide whether you want a pass grade or a letter grade will be May 22nd, which is at the very end of school. So you don't really need to worry about that right now as which one you want. I would encourage you to strive for a letter grade, but you can see kind of how it goes, and we can make that decision at the end of the year. So anyway, I love all of you. I hope you're taking care of yourself. Things have been kind of crazy for me lately, and so I was planning on doing some more live stream stuff, and I probably will at some point, but for right now, with everything going on, I just don't have time to do the live stuff right now. So but we'll definitely get together before the end of the year. Anyway, so now that those logistics are just kind of out of the way, what we're going to be talking about math-wise today, because I went, how long, 5 minutes without talking about math? Oh my gosh, that's crazy. What we're going to be doing math-wise is we're going to be continuing on with volume. Last week we started it, right, when we talked about finding volumes of rectangular prisms and cylinders. And those weren't too bad, just mostly plugging into the formula. And this isn't too bad either. But we're going to be doing what are called pyramids and cones today. So let me I have some examples of pyramids and cones. Where did my pyramid go? Okay. Oh, there it is. Okay. So, a cone is exactly what you think it would be. Oop, sorry there. It's kind of like an ice cream cone, this 3D shape. And then your pyramid is like, oop, sorry, can't tell which way this is. Okay, there we go. The pyramid is like this, right? So like, kind of like the pyramids in Egypt or something like that. So what we're going to be doing is we're going to find some equations to find the volume of pyramids and cones today. And by the end of this, you should be able to find the volume of a pyramid and a cone. And we'll do kind of some fun experiments. We're going to start with finding volumes of pyramids. And how we're going to do that is we're going to compare it to the volume of a rectangular prism. And we're going to use some water to kind of see how the two relate. So we'll go ahead and switch into that, and it'll be good. We'll see you there. Okay, welcome to our highly sophisticated scientific experiment that we're going to be doing today. And we're going to start here with the question of the pyramid, okay? A pyramid is something like this, where you've got a point on the end of it. So if you kind of notice, there's a square on the bottom here. We've got a square here, and then we've got some triangular faces on the sides, and this is a pyramid, okay? So what we're going to do is we're going to look at trying to figure out what the volume of this pyramid is. And how we're going to do that is we're going to use something that we know how to find the volume of. This is actually a cube, but it could be any rectangular prism, and also any pyramid. You could have a rectangular base. Instead of a square down here, you could have a rectangle. But you'll notice here that this cube here that I have and this pyramid, they actually have the same base. When I put them together, sorry, can you see that? The pyramid fits directly inside of the cube. And in fact, if you can kind of tell, they actually have the same height as well. Okay, so this pyramid and this rectangular prism, in this case it's really a cube because all the sides are squares, they have the same height and they have the same base. Okay, and so how we're going to kind of compare the two volumes together, I could find the volume of this, right? I just do length times width times height to get the volume here. So if I can figure out how this volume relates to this volume, I will know how to find the volume of this pyramid here. Okay, so that's what I'm going to do. I'm going to take some water here, and I'm going to very carefully pour it into the pyramid, okay, till we're full, okay. So I'm pouring water in, and that filled up the volume of this pyramid, okay. Now what I'm going to do is pour this into the cube. Okay, so I poured it into the cube. And you probably can't tell, but it only filled up a little tiny bottom part of it. Okay, there's still quite a bit of space in there. Okay, so what I'm going to do next, I'm going to do another. I'm going to fill up the pyramid again and see. I wonder how many of these pyramids fit inside of this cube. Well, let's pour in a second. Okay. There's more in there now, but we're still not full. So let's do another. Okay. There we go. I don't know if you can tell. Hopefully you kind of can. This cube is completely full now. Okay? I kind of finger the top so you can see how the water is at the top of the cube. Okay? So it actually took exactly 3 of these pyramids to go into this cube. Exactly 3 of them. Okay? And that's actually true whenever you have a pyramid. It will take 3 of them to fill up the rectangular prism that has the same base and height. Okay? And so using this will help us find the equation of the volume of the pyramid. So let's look at that now. We'll kind of switch over. Okay, so we saw when we were pouring our pyramid here that we had, and we poured water from it into this rectangular prism or cube, right? We found out that it took 3 of the pyramids to fit inside of this. So now we're going to kind of do that generally. Let's say that I have a rectangular pyramid, so that means it just has a rectangle on the base. Here's where my drawing skills come into play. Here we go. We'll say that that's a rectangle there. And then, of course, it's a pyramid, so it's going to have a point on it. Let's maybe say we go up to there. Got one here. And then like that. Okay, so there's our pyramid. We'll say that this is, we'll call this side the length, this is the width, and then how tall it is to the point from the base. Okay, We're going to call that the height. Okay? And so we want to find an equation for the volume of this pyramid. So we're gonna find an equation for the volume of a pyramid. Okay, so how I'm going to do this is we know that 3 pyramids go into a rectangular prism. So if instead of having a pyramid here, if instead I had a rectangular prism with essentially those same dimensions, again, we're going to have to draw kind of a pretty, okay, so there's our rectangular pyramid. We're going to say that, again, this is length, this is width, and then this, how tall it is height, right? So these are the same in both of them, okay? I maybe didn't draw it to scale the best, but hopefully you get the idea. There were 3 of these pyramids that fit inside of this rectangular prism. Well, the volume of the rectangular prism we talked about last week was we take our length times our width and then times our height, right? That was the volume of that prism. So to get the volume of a pyramid, there would be 3 of these that go into there. In other words, this would be 1/3 of what this is, right? So the volume of the pyramid is, it's going to be 1/3 length times width times height. Okay, so you just literally take the equation for the rectangular prism and just times it by 1/3. Okay, so let's do some examples of this so that you get an idea of how this works. I'll take away our good friends for a second. Got some examples here. Okay, so I've got a pyramid where this length right here is 8, this length here is 8, and then the height, how far it is down from the base up to the top, that is also 8. Okay, and so how would I find the volume of this pyramid? You do 1/3 times the length, so 8, times the width, which is also 8, and then the height is also 8. Okay, so you do 8 times 8 times 8 and times by 1/3. Okay, so let's actually do that. I think we'll get a nasty number. I'll throw that in the calculator for us. So it looks like that turns into about, it's like 170.66, and it just keeps going, repeated 6s. Okay, so normally you're going to want to round to like the nearest tenth or the nearest whole number, whichever one is closer. On the quiz, it should tell you which one. You just pick the one that's closest to the right answer. It's going to be multiple choice on this quiz. Okay, so like I'd probably write my answer here as 170.7, and this would be cubic inches. Okay, so that would be my answer there. That's my volume. Okay, so now let's do the same thing for this other one. This one is a little different because our numbers are all different. We've got a length there of 6, a length here of 11, and then the height is 8. Okay, so we just do the volume of this is going to be 1/3 times these three things. So 6, 11, and 8. Okay. So 6 1/3, well, you could throw this in the calculator. I'm just going to do it by hand because I think it's, well, might be a little bit easier. 1/3 times 6 is going to be 2 times 11 times 8. So 2 times 11 is 22 times 8. That one I'm not sure on, so maybe we should throw that in just to make sure. That is 176. And this would be centimeters cubed. So that means there's 176 1 by 1 by 1 cubes that can fit inside of this pyramid. Okay, so that's kind of fun. So now we know how to find the volume of a pyramid. What we're going to look at next is finding the volume of a cone. Okay, so we wanted to find the volume of something called a cone now. Okay, so a cone is like what it sounds. It is your holder for your ice cream. This is your ice cream cone. I'm not sure if ice cream cone came from the fact that it's just a cone, or if it's probably we named cone first and then they took that and put ice cream in it. So that's pretty neat. You'll notice a cone is somewhat similar to a pyramid, right? It's just, it doesn't have straight edges like the pyramid. It has a circular base, right? We've got a circle here on the bottom, and then it all goes up to a point, but it does so without any edges, right? It just kind of wraps around to give you kind of this pointy shape, okay? Now, lots of things in life are cones, right? I mean, ice cream cones, got fronts of planes are cones, right? You see them all over the place. So we'd like to be able to find out what is the volume of this cone, okay? And kind of like what we did with pyramids, this is kind of like a pyramid. It's a pointy thing, but we want to compare it to something that we can find the volume of, okay? And so that thing is going to be a cylinder, right? I've got a nice little cylinder here. And you'll notice actually this cone and this cylinder, they have the same circular base. The cylinder fits inside of the cone. And when you look at it here, they actually have the same height as well. Okay, so this cone and this cylinder have the same base and height. Okay, so let's see how many of these cones will fit inside the cylinder. What do you think? Well, here's one. Ooh, I dropped a drop. Uh-oh, I think I ruined our experiment. Oh well, sure, it'll be close enough. Okay, we'll do another. It's not quite full yet. Here's a second. Still not full. So let's do one more. Oh, making all sorts of spillage this time. Whoa. Okay, now I don't know if you can tell, but this is really full. In fact, if I just touch the top of this, it's probably going to go over the side, but yeah. So again, it took 3 of these pyramids to fill up this one cylinder, okay? So now let's look at how we would figure out a formula for the volume of a cone. How would we do that? Okay, so we're looking at volumes of cones now, right? And so we had talked about that, or I'd showed you that when you poured water from the cone into the cylinder, there were 3 cones that went inside of the cylinder, right? It went in 3 times equally, okay? So it's kind of similar to pyramids. It's just for pyramids, the shape we were pouring into was a rectangular prism, and for cones, it's a cylinder, okay? But the idea is essentially the same, so let's draw kind of a sketch here. And cones are a lot easier to draw. So here's a cone, there's a cone, okay? And the cone has a, well, it has a radius of the circle on the bottom, so we'll call that R. And then it has how tall it is, okay? And we'll call that H, okay? And we're comparing that to the cylinder, which the cylinder of the same height okay, let's do this. Okay. And then it has the same radius on the bottom of that circle, right? Because those circles are the same. Okay. So we've got our cone here on the left. This is the cylinder. So we already know the volume of the cylinder. We talked about that before. It was we took the bottom here, the area of it, which was pi r squared, and then we times it by the height of the cylinder. So the volume of the cylinder was pi r squared and then times the height h. Okay. The cone is going to be, well, there were 3 cones that went into the cylinder, so the volume of my cone is just going to be 1/3 of the volume of the cylinder. So 1/3 pi r squared h. Okay, so that's my volume formula for a cone. It just has the 1/3 thrown in there, kind of like what we did for the pyramid. So let's look at a few examples of this. Okay, so here's 3 examples of cones. So you'll notice in here that this one down here, this is the radius of the base of the circle. So R is 4 in this case. How tall the cone is right here. And so that's the height is 10. Okay. So how do I find the volume of this cone? Well, I use my formula and just plug in the numbers. So we've got 1/3 pi times r squared, r is 4, and then times the height, which is 10. Okay? And then you throw that in the calculator and see what you get. Or, I guess probably in your case, the computer to see what you get. So we're going to do 1/3 times pi times 4 squared times 10. And this gives us 167.5516, and it keeps going. So I'd probably just round this to the nearest tenth. So I'd do 1.67.6 centimeters cubed, and that would be our answer there. Okay, not too bad. So now let's look at 2 more examples, and then we'll be done. So we've got our cone here. It has 20 miles as the height. This is your height. And then the radius of the circle down here, that's r. So again, to find the volume, do 1/3 times pi times the radius was 10, so 10 squared, times the height, which was 20 in the problem. Okay. So now we throw that in the calculator. And we get a really big number, 2094.395, and it keeps going. I'd probably round that to about 294. Oh, sorry, that shouldn't be there. 2094, and then 0.4 would be my answer there. Okay. Now this isn't too bad, right? You're just taking 1/3 times your cylinder formula. Okay. Now something I do want to mention here before we're done is, let's say that we have a cone turned on its side. Well, if I turned it upright so that it was like these other ones, well, this would be the height, right? The 11 would be the height, okay? And then what's on the bottom is the circle, okay? Well, it tells me that this distance here is 10, okay? Is that the radius of the circle? No, it's actually, this is the diameter. That's the diameter, right? It went all the way across. So how do I find the radius from the diameter? Well, the radius is just half of the diameter. So it would be 5, right, to get halfway there. Okay? So to find this one, you want to be careful that whatever it is doing, it's giving you the radius. If it doesn't give you the radius, if it gives you a line all the way across, that's the diameter. And you'll have to divide by 2 to get the radius. Okay. So the volume here would be 1/3. The radius, well, sorry, pi times the radius squared. So 5 squared. And then times the height, which was 11. And then we throw that in the calculator. So I think that's about 287. Oh, 287.97. Probably just round it up to 288. Okay. Kilometers cubed. So that's how you find the volume of a cone. And hopefully this was helpful. You can go ahead and work on the homework and then take the quiz. Hopefully it shouldn't be too bad after going through this.